Hello everyone. In the last sessions we have discussed about the verification of superposition theorem, right? In today's sessions let us discuss about the verification of Thevenins theorem, right? So we know that Thevenins theorem. What is a Thevenins theorem? Let us consider this is a circuit where ER is going to be the source, okay, and the load is found in between the terminal A and B. We are having another two resistance R1 and R2, right? So first what we are going to do, we are just going to remove the load resistance present in between the terminal A and B, okay. So that is, it is being open circuited. Therefore the voltage across this open circuit point is called VOC, right? Then coming to that, if we are removing the battery, that is we are having only the internal resistance of the battery, that is being denoted by R. If I am looking from this load direction, okay, we could see that the resistance R2, okay, the another pair will be the series combo of this R1 and R. Okay, this R1 plus R will be parallel to this R2 resistance, that is going to be the load resistance or the Thevenin resistance. Okay, now we are just going to replace the entire circuit by a single source with a series resistance, and across which we are going to connect the load resistance RL. Okay, so this is the thing. Getting into the simulation part, as discussed already, we need to combine work with this HTML5 canvas for getting the graphics image, right? So this is a generalized circuit we have, okay. So let me give some values for this R1, R2, R3 and RL resistance, okay. So let me consider, as we did in our lab sessions, let it be the series arm can be 220 ohm and the parallel arm can be connected as 100 ohm, okay, the same circuit. Okay, I am giving the supply as 10 volt and here also we are giving the supply as 10 volt. Okay, now keeping into case 1. What is case 1? Making this DP/dt switch to power and the second switch to the load condition. Okay, that is, we are just going to measure what is the open circuit voltage, or this is a setup where we are going to measure the open circuit voltage, right? Simulate. Okay, so first we are just getting the load current IL by making the S1 to power and S2 to load. Okay, then coming to case 2, in this case 2 only I am just going to make this S1 to power and this S2 to the intermediate condition. Okay, that is I am just going to have this open circuit voltage. Okay, keeping at case 2a, we are just going to determine the Thevenin voltage, or simply we can say it as open circuit voltage. So in this case the first switch is turned to power and the second switch is kept at intermediate condition. Clicking on the simulate, we will be calculating the Thevenin voltage as 3.1250, what we have obtained in our lab, right? Now we are just going to calculate the Thevenin resistance. So keep the mode at case 2b. For this case 2b, what I am going to do, this should be in the short circuit condition and this has to be turned on. Okay, therefore clicking on the simulate, I will be getting what is the resistance value, exactly the same answer what we obtained when we use the multimeter in our lab sessions, right? Now we are just going to use this VTH and RTH and draw the Thevenin circuit, and finally we are going to predict what is the exact load current flowing over here. Okay, keeping at case 3, this case 3 helps to measure the load current. Already we have calculated the Thevenin voltage as 3.1250 and the load resistance is 288.75. Okay, and here the load resistance is kept at 10 ohm. Okay, so even I can change it up afterwards. Okay, click on simulate, I will be getting the load current like this. Okay, fill this data to the table. Now I can repeat the same experiment, okay, for different values of resistance with me. Okay, so case 1, okay, so case 1, this has to be turned to power and this has to be turned to load condition, simulate. Okay, then coming to case 2a, here it is power and this is kept at intermediate so that we can measure what is the Thevenin voltage. Okay, so coming to case 2b, this is to be in the short condition and this is to be at the power condition, simulate. Okay, the same resistance we are getting. Coming to the case 3, okay, so case 3, we are just getting these values. If I simulate, I will be getting the load current as some around 8.03 milliampere. Fill this data to the table. Okay, I can repeat this experiment for n number of times by varying the values of these resistance, and side by side we can verify the Thevenin's theorem clearly. Hope you understand these sessions. Thanks a lot.